Welcome to this explainer. Today, we're diving straight into what is arguably the most mind-bending story ever told, the birth of the universe. It's a deeply evidenced historical event, yet, as you'll see, it's one that still leaves some absolutely profound mysteries completely unsolved. So I want you to start by picturing this. Imagine nothing. And I don't mean darkness, I don't mean cold, empty space, I mean absolute nothingness. No matter, no energy, no space, and there isn't even time.
Right, let's dive into this. Think about that total state of nothingness. And then, in a single, incomprehensible instant, all of space, time, matter, and energy just exploded into existence from a point smaller than a single atom. We are traveling back exactly 13.8 billion years to the Big Bang.
Section 1. What was the Big Bang? Let's quickly debunk the cosmic myth. Okay, we need to clear up a massive mental roadblock right out of the gate. The myth is that you picture the Big Bang as this giant explosion. You know, like a bomb going off in space, expanding outward into some empty void. But the reality? The Big Bang wasn't an explosion in space. It was an explosion of space itself. There was literally no outside waiting to be filled. The very fabric of reality just began expanding from everywhere, all at once. Now, in that very first fraction of a second, and we're talking 10 to the power of negative 43 seconds here, the universe was unimaginably small and unimaginably hot. Trillions upon trillions of degrees. It was so hot that matter as we know it today simply couldn't exist. There were no atoms, no protons, no electrons. It was just this dense, searing plasma of pure energy and exotic particles called quarks and gluons. The very laws of physics themselves were literally just taking shape. And then it started cooling down. Moving on to the first 3 minutes, honestly, the most eventful 3 minutes in history. Let's walk through how this actually builds. At 0 seconds, bam, we have the Big Bang. Just a fraction of a moment later, we're at those trillions of degrees with quarks forming. But within the very first second, those quarks start binding together to form protons and neutrons. By 1 second in, the universe cools to about 10 billion degrees, and neutrinos decouple, flying freely through space. And by minute 3, protons and neutrons fuse into the very first atomic nuclei. You know, I just want you to pause and really think about this for a second. When those neutrinos decoupled at the 1 second mark, they just kept going. Those exact same ancient neutrinos from the very first second of the universe are flying freely through space, and they are passing right through your body right now. Billions of them, every single second. It is a direct physical connection to the first moment of creation. How wild is that? And by that 3-minute mark, the universe had gone through this process called Big Bang nucleosynthesis, which essentially determined its entire chemical composition. It was basically 75% hydrogen, 25% helium, and just tiny, tiny traces of lithium. That's it. That was the entire chemical menu for the early universe. Just 3 basic elements. Which brings us to let there be light, 380,000 years after the beginning. So for a really long time, after those first 3 minutes, nothing much changed. The universe was basically this opaque fog. But 380,000 years after the Big Bang, the universe finally cooled to about 3,000 degrees. And this specific temperature? It's magic. It was finally cool enough for electrons to settle into orbits and combine with those early nuclei to form the first neutral atoms, which were mostly hydrogen. And when that happened, the fog lifted. The universe became transparent. Light could travel freely for the very first time. And that exact moment created something absolutely incredible. We call it the cosmic microwave background radiation, or the CMB. It's that ancient flash of light from 380,000 years after the beginning of time. Because it's been traveling through the expanding universe ever since, it is quite literally the afterglow of the Big Bang. It serves as the universe's baby photo, a perfect snapshot of the cosmos, from when it was brand new. Okay, you just have to love the history of how we actually found this out. Back in 1965, 2 radio astronomers, Arno Penzias and Robert Wilson, accidentally detected this faint, mysterious hiss coming from every single direction in space. They had no idea what they were hearing. In fact, they actually suspected local birds were to blame. They literally thought it was pigeon droppings on their antenna. Seriously, but no, it wasn't pigeons. They had stumbled upon the literal echo of creation. That leads us to evidence of the beginning. How do we actually know all this? So here's the crucial point. We have 3 completely independent lines of evidence pointing to exactly the same conclusion. First, in the 1920s, Edwin Hubble observed that the universe is expanding. Distant galaxies are speeding away from us. If you just rewind that video backward, everything converges to a single point. Second, that 75 to 25 ratio of hydrogen to helium we see everywhere perfectly matches the predictions of Big Bang nucleosynthesis. If the universe was eternally in its current state, the ratios wouldn't look anything like this. And third, that cosmic microwave background we just talked about, it fills all of space at a temperature of just 2.7 degrees above absolute zero, exactly as predicted. This is why the scientific consensus is so overwhelming.
Next up, the great cosmic mysteries, the unanswered questions.
Because for all the concrete evidence we have, the Big Bang Theory certainly doesn't answer everything. In fact, some of the answers we still need are pretty unsettling. Physicists are currently grappling with three massive, wide-open questions. What actually caused the Big Bang? What exactly is dark matter? And what on Earth is dark energy? Let's take these one by one.
First up, what caused it? Well, we have no idea. The laws of physics as we know them completely break down at the very moment of the Big Bang, a point physicists call the singularity. Our equations simply fail. Because time itself likely did not exist before the Big Bang, asking what came before might be a totally meaningless question. It's a bit like asking what is south of the South Pole. The concept just doesn't apply. Then, you look at the composition of our universe today, and the reality is just mind-blowing. About 27% of the universe is dark matter. We know it's there because of how galaxies rotate and how light bends, but we can't see it, we can't detect it directly, and we can't explain what it is. And even weirder, a massive 68% of the universe is dark energy, this mysterious force causing the universe's expansion to accelerate. We named it, we measured its effects, but we have absolutely no idea what it is. Which leads us to a deeply, deeply humbling truth. Everything you have ever seen, touched, or known, every star, every planet, every person, every single atom of ordinary matter in existence makes up just 5% of the universe. The Big Bang gave birth to a cosmos that is mostly a complete mystery to us. Over billions of years, gravity sculpted those early clouds of hydrogen and helium into stars, into galaxies, and into planets. And eventually, on one small blue dot orbiting a remarkably unremarkable star, life emerged, conscious life. When you step back and look up at the night sky, you really can't help but ponder this ultimate question. Where did all of this come from? And that brings us to our conclusion. We are, quite literally, the universe trying to understand itself. And that, perhaps more than anything else, is the most beautiful thing the Big Bang ever created. I hope this explainer really sparked your curiosity and gave you a clear picture of how from nothing, everything began. If this blew your mind, be sure to join us for our next explainer where we are going even deeper to tackle the multiverse. If our universe had a beginning, what if it's just one of an infinite number of beginnings? See you there.